Welcome to Cognitia, where we investigate the biggest mysteries in science, history, and the natural world. Tonight's case is one of the most famous murders in Earth's history. Who really killed the dinosaurs? A ruthless murder was committed. Someone killed the dinosaurs, and for decades, we thought we had the case closed. Witnesses testified that an Everest-sized asteroid slammed into Earth 66 million years ago, devastating the planet and triggering a mass extinction. A simple, dramatic, and convincing explanation. Or is it? In recent years, new evidence has reopened the case and revived an older theory, one that points to a second suspect. A killer not from space, but from beneath our feet. Slow, relentless, and 1,000 times larger than the asteroid. Like any true crime investigation, it's time to re-examine the evidence. 66 million years ago, Earth was barely recognizable. It was the final chapter of the Cretaceous period, one of the hottest and most humid eras in the planet's history. Dense jungles and vast forests stretched across the continents. Even the polar regions were green, hosting prehistoric pines and ferns capable of surviving months of polar darkness. Life was enormous. Pterosaurs ruled the skies. Giant marine reptiles, some over 15 meters long, dominated the oceans. On land, almost every animal larger than a meter was a dinosaur, one of the most successful groups of animals to ever exist, reigning for over 150 million years. And then they vanished. In geological terms, almost instantly. Yes, it is true that around this time, a massive asteroid struck Earth, 10 kilometers wide, releasing the energy of 4 billion atomic bombs. A global catastrophe. But here's the problem. Some ecosystems were already collapsing before the impact. So the question remains, did the asteroid cause the extinction, or did it simply arrive in time to take the blame? To answer that, we need to go back before the impact. At the time, the continents looked familiar, but not quite like today. India was still a massive tropical island drifting northward, covered in rainforests and exotic life. But hidden beneath this paradise was something else. The Deccan Traps dot about 800,000 years before the asteroid. The Deccan Traps began quietly releasing carbon dioxide and sulfur dioxide into the atmosphere, roughly 10 million tons each year. At first, this went unnoticed. No explosions. No immediate disaster. The problem was that the emissions never stopped. Over hundreds of thousands of years, gases accumulated in the atmosphere, slowly altering Earth's climate. Around 300,000 years before the impact, lava began to flow. Not explosive eruptions, but floods. Endless rivers of molten rock poured across the land. Volcanoes stretched beyond the horizon, constantly active. Toxic gases spread through the air. Forests burned. Coastal ecosystems collapsed. India was the first victim. As dinosaurs died beneath ash-filled skies and massive wildfires, at this stage, it still looked like a regional disaster. Terrible, but survivable. Had it ended here, dinosaurs might still walk the Earth today. But the nightmare was only beginning. The eruptions continued for hundreds of thousands of years, and the catastrophe became global. First came warming. Oceans heated by at least 2 degrees Celsius in just 100,000 years. Fast, but not necessarily fatal. Then came the twist. Some volcanic gases heated the planet, while others cooled it. The climate swung violently. Ecosystems that barely adapted to warming were suddenly thrown into cooling. At the same time, sulfur returned to Earth as acid rain. Carbon dioxide acidified the oceans. Plankton, the foundation of marine food webs, began to die. And when plankton collapses, mass extinction is almost guaranteed. Then came the final eruption. About 50,000 years before the asteroid, the Deccan Traps unleashed unimaginable violence. Tens of trillions of tons of magma flooded the surface over several thousand years. Entire ecosystems were buried. Wildfires raged continuously. Earthquakes shattered the land. Tsunamis slammed into coastlines. The heat released may have generated Hypercane's colossal storms with winds approaching 1,000 kilometers per hour, powerful enough to reach the stratosphere, tear holes in the ozone layer, and expose life to lethal solar radiation. Poison followed. Mercury-laden clouds and hydrochloric acid fog rolled across the planet. Acid rain fell on a starving world. Some of the last dinosaurs may have died vomiting toxic foam beneath burning skies. A brutal end for creatures that had ruled the planet for over 100 million years. Eventually, the eruptions slowed. The disasters faded. The planet was devastated, but life clung on. And then, on the other side of the world, a bright dot appeared in the sky. Seconds later, the asteroid struck. If life on Earth was already bleeding out, this was the final blow. Even after the impact, the Deccan Traps continued releasing deadly gases for another 800,000 years, ensuring the planet remained poisoned long after the dust settled. When it finally ended, 75% of all species were gone. Most famously, almost all dinosaurs, except birds, the only dinosaur still alive today. So who was the murderer? The asteroid, the volcanoes, or both working together? The truth is, we don't know. Scientists are still fiercely debating the timeline and severity of these events, and time has erased much of the evidence. But there is something deeply unsettling. At least 4 of Earth's 5 major mass extinctions occurred during periods of massive volcanic activity. The worst of all, the Permian extinction 250 million years ago, was caused by the Siberian traps and wiped out 95% of all life on Earth. This may not have been a random crime. It may have been the work of a serial killer, one that lives beneath our feet. Do we need to worry? No. The monster is real, but incredibly slow and currently asleep. If it ever began to wake again, we would likely have millions of years of warning, time enough to prepare. This was Cognitia, where knowledge meets curiosity, and every answer leads to a deeper question. See you in the next mystery.